Right now, an AI agent that's, just trying to fix a single bug in a code base might talk to itself for 10 minutes. And it could spend like $3 of compute time before it writes a single line of actual functional code.
Yeah, it's literally burning fuel just to think out loud.
Exactly. I mean, for years, the artificial intelligence industry has been obsessed with scale, right? Trillions of parameters, these massive server farms, just an absolute arms race of brute force computation.
Right. Bigger was always better.
Right. But what if we could teach these models to think in silence? What if the next massive leap in AI isn't about building a larger brain, but engineering a radically more efficient one?
Well, I mean, that is the exact inflection point we are hitting right now.
Welcome to the Deep Dive. Today, we have a massive stack of notes on the table covering the July 21st drop from Google DeepMind. We are looking at Gemini 3.6 Flash, 3.5 Flashlight, and Flash Cyber.
And this isn't just a standard version update. It's a complete recalibration of how we measure AI value.
Okay, let's unpack this. We're going to dig heavily into the engineering behind their token efficiency metrics, the new pricing, and what this means for enterprise developers, especially if you're building on platforms like Google Anti-Gravity.
Because the industry is definitely transitioning out of that brute force era we just mentioned. I mean, the initial goal was simply proving that a generative model could solve a complex logic problem.
Right, it's proving it was even possible.
Yeah, exactly. Proving it could write a coherent application. And we proved that. Now, the engineering bottleneck isn't capability anymore, it's latency and cost.
It's lean over large.
Yeah.
But before we get into the actual engineering of how they are lowering token usage, I really want to challenge this July 21st multi-model release strategy itself.
Oh, the three models.
Yeah. I mean, Google DeepMind didn't just give us Gemini 3.6 Flash and call it a day. They presented this entire trio.
Right. Highly coordinated.
You've got the 3.6 Flash headliner. Then sitting right next to it, you've got Gemini 3.5 Flashlight. And then off to the side with a very specific isolated job, you have Flash Cyber.
Yeah, it's a very deliberate spread.
But if you just spent vast resources developing Gemini 3.6 Flash, which is designed to be this incredible leap in efficiency, why release a 3.5 Flashlight right alongside it?
Well, people immediately think of cannibalization, right?
Exactly. Doesn't a cheaper, good enough 3.5 version cannibalize the user base for your shiny new 3.6 version?
It looks like cannibalization if you view AI as a monolithic software product, like a word processor where you only want the user to buy the newest version.
Right, you wouldn't sell Word 97 right next to the new one.
Exactly. But the developers building enterprise AI systems aren't using these models monolithically anymore. They are orchestrating highly complex architectures.
Okay, so they need different tools for different stages.
Exactly. They require entirely different cognitive profiles at different stages of a pipeline.
I see. So if you are building a routing system, you don't send every single API call to the most capable model.
You absolutely cannot afford to do that. I mean, let's say you are a massive e-commerce platform, right? And you're building a customer service pipeline. Okay.
A user opens a chat window and says, "Where is my order?" You do not need the profound reasoning capabilities of an advanced model for that.
Right. It's just a lookup.
Right. So you route that initial query to Gemini 3.5 Flashlight. Its only job is to quickly classify the intent, extract the order number, and hit a database.
And it needs to do that instantly.
Yeah, it needs to respond in like 50 milliseconds, and it needs to cost 1,000th of a cent.
But then what happens when the user follows up with a nightmare prompt like, my order was supposed to be a replacement for a defective product under the 3-year warranty, but the tracking says it went to my old billing address, and I need you to reroute it while prorating the warranty gap.
Yeah, that's exactly where the routing kicks in. That is a multi-constraint logic puzzle. It involves database reconciliation, policy interpretation, external system commands.
Flashlight would just completely crash on that.
It would hallucinate or fail entirely, yeah. So the orchestration layer instantly routes that specific, highly complex prompt to Gemini 3.6 Flash.
Okay, that makes sense. And what about the cyber one? Well, if during that same interaction, the user uploaded a PDF of a suspicious invoice they received, the system might route that document to Flash Cyber.
Just to scan it.
Right, to scan for embedded malware or phishing vectors without risking cross-contamination of the main reasoning engine.
Oh, wow. So it's a dynamic, tiered deployment. It's like a transportation fleet. You don't use a massive freight train to deliver a single pizza.
Exactly. Google isn't competing against itself here. They are trying to provide the entire stack so a developer never has a reason to route an API call to a competitor's model.
Right, they want you to use their scooter for the pizza delivery and their freight train for the lumber.
And by offering the entire fleet, they allow enterprise developers to optimize their token budgets dynamically, which is really what makes the token efficiency metrics of 3.6 Flash itself so critical.
Right, let's get into those metrics, because this is where the underlying engineering becomes really fascinating for you listening at home.
Yeah, the numbers are wild.
The standout data point from the July 21st release revolves around the Artificial Analysis Index. According to those benchmarks, Gemini 3.6 Flash uses about 17% fewer output tokens than its predecessor to arrive at the exact same answer.
Which is huge.
Right. Now, anyone who follows this space knows what a token is. It's the fundamental piece of data, right? The chunks of words or code the model processes.
Right, the basic unit of AI thought.
But I think we need to establish exactly why an output token is treated as such a precious commodity compared to an input token. Like, why is a 17% drop in what the AI generates such a massive engineering flex?
Well, it comes down to the fundamental physics of how large language models generate text. Specifically, the difference between parallel processing and autoregressive generation.
Walk me through that.
So when you feed a massive prompt into an AI, say a 100-page PDF, those are input tokens. Modern GPU clusters can process input tokens in parallel.
Meaning they read it all at once?
Basically, yeah. They can read vast amounts of data almost simultaneously because the entire context is available to them at once. It's highly efficient.
You just dump the whole document into the model's context window, and the compute required to process it is relatively cheap and fast.
Exactly. But output tokens, the actual response the model generates, are entirely different. These models are autoregressive.
Autoregressive, meaning they predict the next step based on the previous one.
Right. It means they generate one token at a time. The model calculates the statistical probability of the first word, outputs it, appends that word back into its own context window, recalculates the entire probability matrix, and then guesses the second word.
Oh, wow. So it's a sequential bottleneck. It literally cannot write the 10th word until it has definitively written the 9th word.
And it gets worse. Every single time it generates a new token, it has to pull massive amounts of data from the GPU's memory into its processing cores.
Wait, for every single word?
For every single syllable, basically. It has to load the entire model weights and the attention cache. This creates what engineers call a memory bandwidth bottleneck.
So the processor itself isn't the problem.
No, you aren't really limited by how fast the processor can calculate. You are limited by how fast you can shove gigabytes of data back and forth across the hardware bus for every single token the AI speaks.
Man. So every output token is a massive, slow, expensive logistical operation on the silicon level.
Yes. And that's why this metric is so important. When we look at the Artificial Analysis Index, which is basically the industry standard scatter plot measuring response quality against latency, and cost a 17% reduction in output tokens is a tectonic shift.
Assuming the accuracy stays the same.
Exactly. To achieve the exact same accuracy with 17% fewer tokens means Google has found a way to make the model synthesize its logic without relying on verbose sequential generation.
Would I have to push back on that?
Okay, go for it.
If an AI model is using 17% fewer tokens to explain a highly complex concept, aren't we inherently losing something? I mean, the density of the information has to go somewhere.
Right, that's the natural fear.
Like if I ask a human expert a difficult question and they give me a 2-sentence answer instead of a 2-paragraph answer, they might be technically correct, but they're probably omitting the nuance, the edge cases, the depth that I actually need.
Yeah, that makes sense.
So is Gemini 3.6 Flash just becoming aggressively, unhelpfully terse just to save compute costs?
Well, what's fascinating here is that this is the immediate concern developers have when they see a token reduction metric. You know, are we just getting a lobotomized, highly truncated model?
Exactly.
But the fact that it hits the same accuracy threshold on the Artificial Analysis Index proves it isn't just chopping off the end of its answers. It's actually about structural logic.
Structural logic. How do you mean?
Well, early language models, and honestly, even models from just a year ago, relied heavily on explicit verbalization to maintain their logical through line.
They had to talk it out.
Right. They would write these long introductory paragraphs. They would restate the prompt. They would hedge their statements. They essentially used output tokens as a crutch to keep their own attention mechanisms focused on the task.
Oh, so they were padding their word count to keep their own train of thought from derailing.
Essentially, yes. It was a functional requirement for them. But what a 17% reduction implies is that Gemini 3.6 Flash possesses a much denser, latent space reasoning capability.
Latent space reasoning, meaning it happens beneath the surface.
Exactly. It doesn't need to write out the intermediate logical steps in English to arrive at the correct conclusion. The computation is happening deeper within the neural network layers, implicitly rather than explicitly on the output layer.
So it's not rambling to find a point, it's just getting straight to it.
Right, and that makes sense for general knowledge queries. But the data shows this gets incredibly aggressive when we look at complex, multi-step engineering tasks.
Yeah, let's talk about that. Because a 17% drop is impressive, but the numbers get truly wild when you look at engineering.
They really do.
The release notes say that on coding, system architecture, and multi-tool workflows, the token usage drops by as much as 65%.
Which is just staggering.
I mean, that is not a marginal optimization.
Mm.
Cutting your output by 65% on an engineering task is an entirely different operational paradigm.
It is. And this is where we really see the mechanics of what Google is calling, quote, trimming unnecessary reasoning steps and eliminating redundant tool calls. This is the core of the engineering breakthrough here.
Okay, let's dissect how this actually works. Because if I ask an AI to, say, debug a Python script that interacts with a database, the AI usually utilizes a technique called chain of thought.
Right. It explicitly writes out its plan before it executes it.
Exactly.
And, chain of thought was a revolutionary prompting technique back in the day because it forced the model to break down a complex problem into sequential, manageable pieces.
It stopped them from just guessing blindly.
Right. But the side effect is that the AI literally generates hundreds or thousands of output tokens that are meant entirely for itself.
Right. The end user doesn't care about the AI's internal monologue. They just want the fixed code.
Exactly. But the AI has to generate, okay, first, I will review the database schema. Then I will check the API connection string. Then I will look for syntax errors in the loop.
And as we just established, every single one of those tokens is autoregressive.
Yes.
So it's eating up memory bandwidth, it's driving up the latency, and it's basically just burning the developer's API budget.
And that gets exponentially worse when you introduce tool calls. Modern agents are given access to external environments now, right?
All right, they can ping a search engine or run a script.
Exactly. They can run a search, query in SQL database, or execute code in a secure sandbox.
So a less efficient model, using explicit chain of thought, might encounter an error, write a whole paragraph analyzing the error, write a query to search the database, wait for the database to return a giant JSON file.
Read the file, write another paragraph summarizing what it found, and then realize it queried the wrong table.
Oh, man. And then it loops.
And then it loops. It generates more tokens to correct itself, makes another tool call, and the cycle just continues. This is what they mean by redundant tool calls.
The AI is essentially thrashing.
Thrashing is the perfect word for it. It's burning through context window limits and token budgets, just trying to orient itself in a complex environment.
It's exactly like watching a junior developer on their first major project.
Oh, that's a great analogy.
Right, because a junior developer will write a single line of code, immediately compile it, get an error, Google the exact error message, open 5 Stack Overflow tabs, paste the solution, compile it again, get a new error, and start over.
Yeah, every single cognitive step is externalized, tested, and highly inefficient.
But a senior developer doesn't do that.
No, not at all. And what Google has engineered with Gemini 3.6 Flash is the equivalent of a highly experienced senior developer.
Because a senior engineer doesn't compile after every line.
Right. They look at the architecture, they hold the schema in their working memory, they map out the logical dependencies implicitly, and then they sit down and write a clean, integrated block of code in one continuous flow.
They do the heavy lifting in their head, not on the keyboard.
Precisely. By optimizing the internal routing and the latent reasoning layers, 3.6 Flash can hold a complex, multi-step goal in its context without needing to constantly verbalize its progress.
Or endlessly ping external tools just to verify its assumptions.
Right. It trims the unnecessary reasoning steps because its internal confidence and structural mapping are vastly superior.
Wow. So think about this. If you're listening and you build these systems, that 65% reduction isn't just a cost-saving measure, then. It's a massive acceleration of execution speed.
Oh, absolutely.
Like if I'm sitting there watching a terminal window while an AI agent tries to refactor a legacy code base, a 65% reduction in output tokens means I am waiting a fraction of the time for the final output.
Because the progress bar isn't just hanging there while the AI talks to itself in the background.
Exactly. And latency is arguably more important than cost for certain enterprise applications.
Definitely. I mean, if you are building a system that requires real-time user interaction, you cannot afford a 5-second delay while the model engages in a redundant chain of thought loop.
Which brings us perfectly into the application layer. Knowing how the model achieves this latent efficiency leads us directly to the developers who are actually wielding this tool.
The people in the trenches.
Right. Now, the July 21st release notes that 3.6 Flash is available in the Gemini app and to developers through AI Studio, Android Studio, and third-party tools. But the platform that stands to benefit the most profoundly from this is Google Anti-Gravity.
Yes. We absolutely need to spend some serious time unpacking this because anti-gravity is where the real enterprise magic happens.
For sure. Because anti-gravity is meant to facilitate building these complex systems, right?
Right. It's Google's premier orchestration platform for building highly autonomous, multi-agent AI systems. It's not for building a simple chatbot.
It's for persistent systems.
Right. Yes. It is designed for developers who are constructing persistent digital workforces.
Okay, let's create a hypothetical scenario to ground this for you guys listening, because multi-agent orchestration can sound like a lot of buzzwords.
It really can.
Let's imagine a global logistics company. They use Google Anti-Gravity to manage their supply chain. They don't just have one giant AI, they have an interconnected grid of specialized agents.
That is exactly how these systems are designed in the real world. In your logistics scenario, you might have, say, Agent Alpha constantly monitoring global weather data APIs and port traffic.
Okay.
Then you have Agent Beta monitoring the internal inventory databases and current shipping manifests. And you have Agent Gamma, which is actually authorized to execute rerouting commands and purchase emergency freight capacity.
Okay, I love this setup. So a massive typhoon develops in the South China Sea.
Right.
Agent Alpha detects the anomaly in the weather API, cross-references it with port closure reports, and flags a critical disruption. It has to pass that information to Agent Beta.
And this is where token efficiency traditionally creates a catastrophic bottleneck.
Really? Just in the handoffs?
Oh, yeah. In an orchestration environment like anti-gravity, agents communicate with each other by passing context. Agent Alpha has to summarize its findings and send an output payload to Agent Beta.
And if Agent Alpha is using an older, inefficient model?
It might generate a massive, rambling, token-heavy report detailing every single weather station it checked, its entire chain of thought process, and 5 redundant tool calls it made to verify the wind speed.
It basically floods Agent Beta with a massive wall of text.
Yes. And Agent Beta has a limited context window. If Agent Alpha floods it with useless reasoning tokens, Agent Beta might actually lose critical older instructions from its own system prompt.
Oh, it pushes the important rules out of its memory.
Exactly. Furthermore, the time it takes Agent Alpha to auto-regressively generate all those unnecessary output tokens delays the entire system.
Because it's generating them one by one.
Right.
So the typhoon is moving in real time, but the AI system is bogged down because the agents are basically writing each other novels instead of bullet points.
Exactly. And then Agent Beta has to process that massive input, figure out which cargo ships are affected, and pass a recommendation to Agent Gamma.
And if every single agent in this pipeline is burning through explicit chain of thought tokens,
the system becomes incredibly slow. It becomes highly fragile due to context window flooding and outrageously expensive in API costs.
but when you swap the underlying engine in anti-gravity to Gemini 3.6 Flash, that 65% reduction in complex engineering tasks fundamentally redesigns the architecture.
It changes everything. Let's look at the same scenario. Agent Alpha detects the typhoon. Because it has superior latent reasoning, it doesn't need to write out its thought process.
It doesn't make those redundant API calls.
Right. It doesn't make redundant calls to the weather database. It simply processes the anomaly internally and outputs a highly concise, incredibly dense data payload.
Like typhoon identified, port X closed, expected delay, 48 hours.
Exactly. It passes that directly to Agent Beta. Agent Beta receives a clean, minimal input, meaning its context window isn't bloated at all.
So it can instantly map the affected cargo.
Right, and it passes a minimal, precise command to Agent Gamma. The 65% reduction in token usage translates to a frictionless flow of data between autonomous agents.
So the latency drops from minutes to milliseconds.
Milliseconds, yeah. The API costs plummet. And most importantly, because the agents aren't constantly bumping up against their context limits with their own verbose internal monologues, developers can build agents that run persistently.
Persistent agents. This is a massive shift.
It's the holy grail of agentic AI.
Because historically, developers fire up an agent, Give it a task and shut it down. Because leaving it running is like leaving a taxi meter running while the car is parked.
Exactly. If the model is inefficient, it's constantly burning tokens, just maintaining its state.
But with 3.6 Flash on anti-gravity, developers can finally deploy persistent digital workers that monitor complex, ambiguous environments 24/7.
It completely lowers the barrier to entry. If you are building an Android Studio or anti-gravity, you can experiment so much more freely now.
Right. You can let the system ingest vastly larger data sets and tackle much harder problems because the underlying engine is sipping computational fuel rather than guzzling it.
Yeah, it just completely changes the economics of development.
But if I'm a developer using anti-gravity today, how does this alter my day-to-day workflow? I mean, for the last 2 or 3 years, the entire discipline of prompt engineering has been about micromanagement, right?
Oh, heavily.
Developers write these insanely brittle, highly specific prompts, like think step by step. Do not use external tools unless X is true. Format your output exactly like Y to save space.
Yeah, we've all written those prompts.
Right. But if the model is now handling this efficiency internally, does prompt engineering become obsolete? Do I stop worrying about optimizing my prompts and just let the model's internal efficiency do the work?
Well, obsolete is too strong a word, I think. But the nature of the discipline is going to shift drastically. The era of micromanaging the AI's internal thought process is ending.
So you don't need to hold its hand anymore.
No. If you are building an anti-gravity today with 3.6 Flash, you don't need to explicitly instruct the model to avoid redundant tool calls. The model's architecture already penalizes that behavior implicitly.
So you stop being a micromanager and start being a systems architect.
Exactly. You transition from managing the workflow to managing the outcomes and the boundaries.
Like setting the rules of the game.
All right. Your prompts become more about defining the parameters of the sandbox. You say, you are Agent Gamma. Your goal is supply chain optimization. You are authorized to spend up to $50,000 on emergency freight. Optimize for delivery speed over cost in this specific geographic region.
You give it the goal, and you trust the latent space reasoning of the model to find the most computationally efficient path to that goal.
Yeah, and this frees up so much developer bandwidth. Instead of agonizing over whether a specific agent interaction is going to spike the token budget and crash the application, the developer can actually focus on adding new features.
Integrating new data streams, scaling the product.
Which brings us to the raw economic reality that is currently reshaping the enterprise AI landscape. Because this developer empowerment is fundamentally tied to the pricing structures announced in this release.
Yes, the financials here are aggressive. The pricing for Gemini 3.6 Flash is set at 1.50 cents per million input tokens and 7.50 cents per million output tokens.
Which is a notable cut from the prior generation's baseline.
A steep drop.
Mm-hmm.
But the true economic impact isn't just a flat discount on the sticker price, is it? It is the compounding effect of the token reduction we've been discussing.
Right. If we connect this to the bigger picture, this is the double win that is forcing every enterprise CTO to recalculate their budgets.
Let's do the math on that.
Okay, let's look at the math. Google has physically cut the price they charge per million tokens. The raw unit of fuel is cheaper. But simultaneously, the model requires up to 65% less of that fuel to complete a complex task.
So you are paying a lower price at the pump, and your car suddenly gets triple the gas mileage.
Exactly. When you multiply a lower baseline rate by a massively reduced consumption volume, you see an exponential drop in the actual real-world cost of operating an AI system at scale.
Right. So if you're running an automated coding assistant across an enterprise with 5,000 engineers.
Or managing that anti-gravity logistics grid processing millions of API calls a day.
The operating overhead just plummets.
It does. And this alters the primary metric that businesses use to evaluate artificial intelligence entirely. We talked earlier about how benchmark scores used to be everything.
Right. Everyone wanted the model with the highest theoretical IQ on some standardized test.
Exactly. But now we are seeing a massive shift toward calculating the price per completed task.
How much does it cost to get this specific job done?
Right. Return on investment is taking over from research and development. If Model A has a slightly higher theoretical score on a graduate-level physics benchmark, but costs $2 to refactor a block of code.
And Gemini 3.6 Flash can refactor that exact same block of code perfectly for 15 cents.
That enterprise market is going to choose the 15-cent option every single time.
Here's where it gets really interesting, though. Because it's the commoditization of intelligence. AI is transitioning from this wondrous, almost magical experiment into a standard utility bill.
It's becoming like AWS cloud storage or electricity.
Exactly.
Yeah.
But I have to introduce a massive caveat here, because whenever we talk about radical increases in efficiency and radical drops in price, we have to talk about Jevons paradox.
Absolutely.
For those of you listening who might be unfamiliar, Jevons paradox is an economic concept from the 19th century. William Stanley Jevons observed that when technological improvements increased the efficiency of coal use, the overall consumption of coal did drop. It skyrocketed.
Because it became so much more useful.
Right. Because it became cheaper and more efficient, people invented entirely new use cases for it. They built more factories, and overall demand just exploded.
And that is exactly what we're going to see with AI compute.
Are we? I mean, are we just looking at Jevons paradox for compute? If Google makes Gemini 3.6 Flash exponentially cheaper and faster to run on platforms like anti-gravity, enterprise developers aren't going to spend less money on AI, are they?
No, they're just going to build wildly more complex, sprawling systems.
So the total enterprise spend on AI is going to go up, not down. Are we risking a race to the bottom where companies prioritize cheap answers over the absolute best answers, or is this just induced demand?
Well, from Google DeepMind's perspective, that is a feature, not a bug. They are actively banking on Jevons paradox.
We want to induce demand.
Entirely. By dropping the friction of cost and latency, they make it economically viable to embed AI into processes where it previously made absolutely no financial sense.
Give me an example of that.
Okay, a year ago, you wouldn't use a frontier model to silently format every single cell in a massive Excel spreadsheet, right?
No, of course not. The API calls would cost more than the analyst's salary.
Exactly. It was prohibitive. But if the cost drops to fractions of a penny, suddenly you deploy a background agent to watch every single keystroke across the entire enterprise software suite, looking for optimization opportunities in real time.
Oh, wow. So they don't want you to use the model less. They want you to use it 1,000 times more for every conceivable micro task.
That is the new battleground. That is the race to lean. Over the next few months, you are going to see efficiency become the central battleground among all the frontier labs.
Because the era of the bigger is better flex is over.
It's rapidly closing, yeah. Putting out press releases bragging about training on 10 trillion parameters in a 2-gigawatt data center, it's unsustainable.
And developers are rejecting the massive latency overhead that comes with those behemoths anyway.
Exactly. The new Flex is telling the market, look how little it costs to run our model at scale.
It's an incredible shift in the narrative. We finally built a supercomputer, we achieved these astonishing feats of generative intelligence, and the immediate, urgent next step for the entire industry is trying to figure out how to run it on a AAA battery.
How to optimize the software so it can run ubiquitously, silently in the background of every piece of technology we own.
And we are already seeing this lean philosophy move up the stack, aren't we?
Yes. Google actually teased an updated Gemini 3.5 Pro model alongside this July 21st release.
And the Pro designation is usually reserved for their highly capable, larger-scale reasoning engines.
Right. So the fact that they are bringing this hyper-efficient token trimming architecture to the Pro line implies that this isn't just a strategy for their lightweight models.
They are re-engineering the very top of their capability curve to be just as cost-effective.
And rivals are going to have to respond instantly.
They don't have a choice.
No. Because if you are a competitor and your flagship model still relies on explicit token-heavy chain of thought, you are going to get priced out of the enterprise orchestration market entirely.
Because developers building on anti-gravity or equivalent platforms simply won't tolerate the latency or the API bills.
Right. The entire ecosystem is going to shift toward models that prioritize latent space reasoning and minimal tool calls. It is the only way to scale these digital workforces economically.
It's an amazing technological pivot. Think about your own tech consumption for a second. How much more willing are you to rely on an AI assistant if you know it costs pennies a day versus dollars an hour?
It changes the relationship entirely.
It really does. But, as we look at the reality of this transition, the move toward implicit latent space reasoning, the deliberate trimming of explicit chain of thought tokens, it brings up a pretty serious secondary consequence.
The auditability problem.
Exactly. If the future of AI development relies on these models systematically hiding their reasoning steps to save us latency and API costs, if they stop thinking out loud, what happens when things go wrong?
That is the crucial architectural trade-off we are making right now. The explicit chain of thought was expensive and it was slow, but it provided an invaluable audit trail.
Right. Let's go back to our anti-gravity logistics hypothetical. If Agent Gamma suddenly decides to route 500 shipping containers to the wrong continent, costing the company millions of dollars, the developers need to know why it made that decision.
And in the older, less efficient system, the developer could just open the logs and read the explicit internal monologue.
They could see the exact token where the AI misinterpreted the weather data.
Or the exact redundant tool call where it pulled the wrong port code from the database. The reasoning was transparent because it was generated as output tokens.
But if Gemini 3.6 Flash trims all those steps and does all that heavy lifting implicitly inside its own neural network layers just to save us money, how do you audit it? How do you subpoena a latent space?
Well, you can't, or at least it becomes exponentially more difficult.
That's slightly terrifying.
It is a real concern. As we optimize these models to be lean, fast, and cheap by pushing the reasoning deeper into the black box, we are actively sacrificing our ability to observe their logic.
We're literally trading transparency for efficiency.
Yes. If it stops showing its work to save us a few cents on the utility bill, we might lose the only mechanism we have to debug the system when it makes a high-stakes, catastrophic mistake.
So when the black box gets leaner and faster, it also gets darker.
That's one way to put it, yeah.
That is an incredible paradox to leave on. The drive for efficiency makes the technology ubiquitous, but it might just make it fundamentally harder to control.
It's the next great engineering challenge.
Well, we've covered a massive amount of architectural ground today. From the tiered deployment of the Gemini 3.6 Flash family on July 21st to the memory bandwidth bottlenecks of autoregressive output.
And the profound implications of implicit reasoning for developers orchestrating those persistent agents on platforms like Google Anti-Gravity.
Exactly. The AI arms race is no longer about size. It's a relentless race for efficiency. Keep questioning the architectures you are building, keep looking beneath the surface of the API calls you make every day, and we will see you on the next Deep Dive.